Well, hello and welcome YouTube, Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside. Today we are going to be looking at 3D circles, otherwise known as spheres. I have 11 practice problems for us to do, and I feel like they're pretty, they're not all samey, but they're all spheres, and it's hard, you know, they grow and shrink in the same kind of format there, so they're pretty standard run-of-the-mill. I think after you get a few, you're going to make sense of it. They want to try and throw some wrinkles in at you with the information they give you, and we're going to be looking at a few composite figures, but this should go a lot faster than my pyramids and cones one. I don't even think we have any word problems. Can't guarantee it, but hey, let's get started. Okay, so it's numbers, no, I think it's only 10 problems actually. I do numbers 2 through, we'll see, 2 through 11, let's see. 2 through 11, guys, that's only 10 problems. Sounds good. All right, starting with this number 2. Oh, by the way, I have a calculator for these because round to the nearest 10th, and we'll be using the pi button, and then later we'll do in terms of pi, whatever. But here we go. Find the volume of the sphere, round the answer to the nearest 10th. Now, spheres do have radii, just like circles do, because a radius is just distance from center to edge of a circle or of a sphere. Now, the volume of the sphere, guys, the way that we're going to find them, here's your formula. It is 4/3 pi r cubed. Like I said, spheres have radii. Here's your formula. We are not going to find the area of a circle first and then multiply by something. It's kind of a different format here. I can't really dive into a proof with you for this unless it's a lot higher end thing. You need calculus because you need integration with it. But this is the this is the go-to for it. And, round to the nearest 10th afterwards. So here we go. We have a radius of 3.7 inches right here. So our volume is going to be 4/3 times pi times the radius cubed right there. And I'm just going to enter that in the calculator and you round to the nearest 10th. It's that easy, or it's that, straightforward. It is kind of one step of writing and then one step of doing. So if I go to my calculator here, I'm going to go ahead and take 4/3 and multiply that by pi and then by my radius and cube, and cube that guy right there, and we get an answer. That's 212.17, so 212.2 if you round to the nearest 10th. Here we go. So that's about 212.2, and this is cubic inches, like that. There you are. That's number 2. Number 3, let's use a different color because I'm leaking over. We have a diameter of 11 feet. So we need to find the radius there by dividing that by 2, which is going to be 5.5, and that is feet. So your volume is once again 4/3 pi r cubed, and it's one of those things where once you really start to feel this out, you don't really need my help with something. It's just when do they give you a new kind of problem, because all of them are literally just formulas, but this organization tactic's a lot cleaner than all the other ones when we did pyramids and such, because there's just a lot more to do in those problems. This is just kind of plugging this in. In fact, I'm going to recall my previous statement and just type this part out again like that instead. 4/3 pi r cubed like this, round to the nearest 10th, 696.9. That was set up very well. So the volume's approximately, here we go, 696.9 cubic feet. There you go. Number 4, this time you have circumference of what they call the great circle. Because if you can imagine, guys, there's also even a circle way up here that can be, made within the sphere in of itself. But the great circle is the largest, it's kind of the equator of this, bezel. It's the largest rim and ring around this sphere that you can make. So the circumference of the great circle, the thing that's important for that is we know that the radius does hit that mark in such a way that we could then determine the radius of not only that great circle, but also of the sphere at the same time. So the circumference of the great circle is 14 pi centimeters. Now the circumference of any circle, guys, is 2 times pi times your radius. So if 2 times pi times the radius is 14 pi, we can divide both sides by pi, the pi's go away. We can divide both sides by 2, and we get a radius of 7 centimeters. Okay, so that is the radius of this one right here. And so now we do the same thing, 4/3 pi r cubed here for the rest of it. So volume is 4/3 pi times radius cubed, and I don't know. 7 cubed is 343, but I don't know 4/3 of that number, and we got to get the pi part anyway. So I'm going to go to the calculator here. I hope you're okay with me kind of not showing it. 7 cubed. Now I'm getting 1436.75, so 1436.8. That's about 1436.8 cubic centimeters right there. That is the volume of your sphere. All right? So that's the first three. The next three are very same-ish. We have diameter, radius, and this time area of the great circle, but this time we're going to leave our answer in terms of pi. So I'm going to leave pi out of my calculations, and I'm going to insert pi into the answer, if that makes sense. You'll kind of see it here. All right, 20 centimeter radius. 20 centimeter radius means that you're, and you know, actually furthermore, if my answers are in terms of pi, I tend to like to leave my answer as a fraction as well if I can work with it. Meaning if they already give me decimals to play with here, I'm going to just deal with the decimal. But 11 I might just leave as 11/2 and, you know, do something with the 4/3 and stuff. So you'll see me play with this in different ways, because once you hit pi, you know, I don't want to use a decimal. I don't know how to explain it. So you'll see me play with fractions, I think, sometimes here as well. I'll give you the decimal equivalent if there's no rounding. But if I have to divide by 3, then there's rounding. So anyway, here we go. So 20 centimeters here is the diameter. So your radius is 20/2, which is 10 centimeters. So the volume of this one, once again, 4/3 pi r cubed. So pi times the radius cubed. So check this out. I'm going to go calculator free on this one here. They do say leave the answer in terms of pi. 10 cubed is 10 times 10 times 10. That's 1,000. All right, so we're going to take 4/3 of 1,000 and multiply that by pi. Now, 4 times 1,000 is 4,000, so that'll become 4,000 times pi all divided by 3, or 4,000 pi, you know, however you put it like that. But this is an exact answer. This is cubic centimeters. This is an exact answer right here. You can use the calculator, do 4,000 divided by 3, but check this out. If I go to the calculator here and I do 4,000 divided by 3, you are going to get a repeating decimal. 1,333.3 repeating. So they didn't ask you to round the decimal to the nearest tenth when you leave in terms of pi. They said leave your answer in terms of pi. Basically, they want you to give an exact answer, as exact as you can. That's why they say leave pi in there. Nearest tenth means, hey, it's okay to round. It's okay to play with decimals and do that. But here, this is the best answer you can give, especially for this problem. If all of them have 4/3, often, unless you can divide by that 3, it's going to be likely that you have a repeating decimal. So, you know, just kind of be aware of that. And that's kind of what I'm playing with on these ones. All right, your radius is 1 meter on this guy right here. And so the volume on number 6 here is 4/3 pi r cubed. 1 cubed is 1. 1 times anything is just that something. So your volume here is 4 pi over 3 cubic meters. That's your final answer. That's all I got to leave with there. So once again, it's an exact answer in that way. Now, pi over 3, guys, is pretty close to 1, right? So this answer is pretty close to 4 in general. Just like this answer is pretty close to 4,000. Whenever it's over 3, that's what you'd get in the end. All right, number 7, the area of the great circle, as we talked about, is 81 pi square inches. Now, the area of any circle is going to be pi r squared. That means that this pi r squared here also equals 81 pi. Let's find that radius based on that idea. We can divide both sides by pi, and they do cancel out there, so you're left with r squared is 81. If I take the square root of both sides, I get r equals plus or minus 9, but because we're talking about a length, we're only looking at the positive version of it. R is 9 inches. That's our radius, 9 inches there. Okay. So our volume is going to be 4/3 times pi times 9 cubed. All right. 9 cubed is 729. So we're going to have 4/3 of 729 times pi. Now the cool thing is 729 is divisible by 3. I don't know what it is though. Now I have to think about it. I don't know what it is. Let's do 729 divided by 3. 243? Yeah, 243. Okay, so 243. Now 243 times 4. I'll just go and calculate that because I don't want to mess that up. I think it's 900, there we go, 972. So this is going to be 972 pi. That's exact, no decimal kind of needed. But when I calculated, guys, I left pi out of my calculation because pi is in the answer. Oh, I need units because pi is in the answer. So this is cubic inches right there. That's the volume. All right, we're more than halfway there as we've done 6 problems. The rest are, I think, composite figures or kind of something of that nature. So you're kind of seeing the 4/3 pi r cubed come into play. Very straightforward, but you're seeing what I'm doing with the exact answers on those ones. Just follow the instructions with what's provided from your teacher, from a book, from a website, whatever it is, and you should be all set. Moving on to the next page here. I have 2 composite figures here and 2 composite figures here, all which kind of focus on what look like a lot of hemispheres, you know, half spheres. Now, two hemispheres make a whole sphere there, but there's a hemisphere, there's a hemisphere, there's a hemisphere. Is it hemisphere or semisphere? On the Earth, we call it hemisphere, and 1/2 the sphere. Anyway, find the volume of the composite figure, leave the answer in terms of pi. Once again, I'm going to go in the exact route. Now, I also have a cylinder within this thing. So if I do combine these 2 hemispheres, then I do get a full sphere. So imagine that we have the full sphere, you know, like this guy right here. I don't really know how I want to draw this. I'll just draw it like that. Imagine that you have a full sphere, and it would have a radius of then 2 feet. We're going to find that volume. I'll call that figure 1. In figure 2, we have the cylinder. Okay, figure 2, we have the cylinder right there, also with a radius of 2 feet. Now, we're doing 2 completely different calculations here with regard to the radius that's provided. Even though the radius is the same thing, I never have to use area of base for this thing, even though I do here. Oh, by the way, the height of that is 5 feet. And this is figure 2. So the volume of figure 1 here is just done by 4/3 pi r cubed. 2 cubed is 8. 4 times 8 is 32. So here I'm left with 32 pi over 3 cubic feet. Excuse me. Now, I want an exact answer here anyway before I do any of the addition because I want to make sure that I don't round early anyway. So even if you did go around to the nearest tenth for your final answer, you're not going to round yet right here. You're going to wait until you get some more. So to get the volume of the second one, we have to first find the area of the base of the second one here. So pi r squared, pi times radius squared is going to give us 4 pi square feet. And then the height of this, as we said before, is 5 feet. So the volume of the second guy is going to be area of base times height, which is going to give us 20 pi cubic feet. Okay? So we have both of these 2 volumes here. The volume of the total thing is going to be these added together. Remember, I put these 2 hemispheres together to make a full sphere there. And then, so I added those 2 already. You know, that's the volume. I already added those 2 together. And then the cylinder right here, I just got to add in with it. So the volume of the total is going to be those 2 volumes added together. We're going to get 32 pi over 3 plus 20 pi. And listen, they say leave your answer in terms of pi. And like I said, I'm not going to do any rounding outside of it. So I'm going to alleviate myself of calculator work right here, and I'm going to continue with what I have. I need to find a common denominator. 20 pi can also be written as 60/3 pi, 60 pi over 3, because 60 divided by 3 is 20, and I need to get that 3 with it. So that's going to be 32 pi over 3 plus 60 pi over 3. I multiply top and bottom by 3, and that'll give me 92 pi over 3 cubic feet. That can't be reduced. That can't be divided further. That's all we have left for that one. That's it. That's all. That's in terms of pi. Best answer you can get, or you can write to be exact. Okay, number 9. Now, what often happens with these ones, if I can imagine, is we have a petri dish, if you will. We have a full cylinder, and then we have a little thing kind of cut out of it, kind of carved out, little hemisphere again, if you will. Now, this time there is just one hemisphere. So when we find the volume of that little guy, I can call that volume 1 if you, I'll call it volume 2 because I'm going to subtract that one from it. When we find volume 2, remember that when we find the volume of the sphere, we're going to have to take half of it. And I'll kind of be sure to incorporate that into my formula when I do. Okay, so we do have another cylinder though, so we're going to have the area base times height stuff as we had before. Now we do have an 8-inch radius on the cylinder. So the radius here is 8 inches, whereas the radius of the hemisphere there is 2 inches. So with this one, the height of that guy is also 3 inches. And let's find the area of the base of the cylinder. That's going to be pi times the radius squared. I'm just making sure all my numbers are right because I made a vow to not make mistakes this time. Let's make sure that they're correct. So we get 64 pi square inches for the area of the base. And then the volume, therefore, of that whole thing is going to be area of base times height. And again, this is in terms of pi. So this is going to be 64 times 3 is 192. So 192. Oh, you can't see any of this. I'm very sorry. That's 192 pi cubic inches there. That's the volume of the cylinder. And then we're going to subtract the hemisphere here. And remember, it is a hemisphere. So we are going to, for the volume, it is 4/3 pi r cubed, but then we gotta take half of all that. I probably should have put the half in front. Really what I'm going to do is I'm going to take half of 4. I'm going to take half of 4 right there. Cut that out, get that 2 there. Does that make sense? So volume of the second guy, so we already did the half. The hemisphere part's taken care of. So this is 2/3. 2 cubed is 8, so 2/3 of 8 times pi. 2 cubed is 8. 2/3 of that times pi. 8 can't divide by 3, but 8 times 2 is 16. So we are going to get 16 pi over 3 cubic inches. So that's the volume of the second guy there. And now we have to subtract the volume of the hemisphere from the volume of the cylinder to get the volume of the total. So the volume of the total here, once again, it looks like a common denominator is going to have to come in place. But we got 192 pi minus 16 pi over 3. I got to multiply top and bottom of 192 by 3 here. I don't know 192 times 3, but it's 200 times 3 is 600 minus 3/8, which is minus 24, which is 576. So we have 576. Actually, I had a faster way to do that. We have 576 pi over 3 minus 16 pi over 3. Okay, and that will give us 560 pi over 3, if I did all that right. And that's going to be cubic inches. This one cannot reduce or divide any further. We are set with that one. That is the final volume of that composite figure. All right, I have 2 more. They are going to ask us the numbers 10 and 11 to round to the nearest 10th, and these are the final 2. I hope you're feeling out this pi stuff with it and revisiting the prisms and cones now alongside the cylinders that we just saw. All right, we're going to add the volume of one on top of the other. Once again, another hemisphere. Because we're adding them, doesn't really matter which order I do it. I'll go ahead and call this volume 1 and call this one volume 2. So the radius of volume 1, or of the hemisphere there, is 3. I guess the other one doesn't have a radius, so that's really no bother to me. But the volume of that first guy there is going to be, remember last time, this is a hemisphere. Half of 4/3 is 2/3. I'm going to go ahead and write that right now. 2/3 pi r cubed. You know, kind of feeling that one out. This is 3 times 3 times 3 and then divided by 3, right? So 27 over 3. Yeah, I'll do this in order. I don't want you to get lost in how'd you get that number. So 2/3 of 3 cubed is 27. That's pi. 2/3 of 27 straight up. That's 18. So that's going to give us 18 pi cubic centimeters for the volume of the hemisphere. The volume of the rectangular prism here, we are going to first come up with the area of the base. The area of the base here, I'll do 10 times 8 there. That's 80. And then the height of this guy is 4 centimeters. So the volume of this total thing is going to be area of base times height, and that is 320 cubic centimeters. So now we have 320 cubic centimeters and 18 pi cubic centimeters here. So the volume of the total adds the 2 up, and we are going to be getting, so 320 plus 18 pi cubic centimeters to start off with. They do want us to round to the nearest, I think 10th. Round to the nearest 10th here. Now, if they wanted you to leave your answer in terms of pi, I want to let you know that this would be the final answer. I would not turn this into 338 pi. because this doesn't have pi in it. These are like unlike terms. If this was like an x, you don't combine these two things. They are unlike. This doesn't have a factor of pi. So they do want me to calculate this though. So this is not a final answer. I still must actually add this in the calculator. So when we go to it, I'm going to do 320 plus 18 pi. I'm really on a mission to finish this within 25 minutes if I can, because I feel like I owe it to you guys to have a shorter video compared to the longer videos I've had recently. Nearest tenth would be 376.5 cubic centimeters. So 376.5. What is flashing behind me? I'm sorry if you're I'm sorry about that commercial, guys. If you're looking at my thumbnail thing as I'm writing this. 376.5 cubic centimeters. There's my final answer. I have one more, and within this one, I don't know if they're going to play any trickster games. Not really. They have everything kind of in place. No Pythagorean theorem, no kind of divulging information out from what's given. We use what's there, and we go from that. So in this last one here, we do have a cone though. So kind of going back to what you maybe saw in my last video. Hang on, I'm trying to drag this over. What you maybe saw in my last video. Haha, I got you. Volume 1. So I think we're carving the hemisphere out of the cone. And a lot of hemispheres are kind of jumping into here. I'm really surprised. Actually, I'm not with this book. But, you know, it no longer shocks me. But I am surprised that they don't do one where you just find a volume of a hemisphere first in your own practice before saying, let's do it in a composite figure, right? So anyway, here's figure 1, here's figure 2. So my figure 1 is going to be the cone. All right, within that cone, we are going to do your volume of your cone. Your volume of 1, this is going to be 1/3 area of base times height. Our area of our base is our circle, okay? So just so you're aware of what we're going to be doing there as a revisitation. So the radius of the cone is 10 millimeters. That's 10 millimeters. And so therefore the area of the base of that thing is going to be pi times r squared, and that's 100 pi square millimeters. We haven't done many with millimeters. I think we've done that maybe once or so, but this is first time for a while. Your height of this guy is 24 millimeters here. So the volume of your cone is 1/3 area of base times height. And we are going to go to the nearest tenth in the end, but not yet. You don't want to round early. I'm going to leave this volume in terms of pi to begin with until I do the subtraction part later. 1/3 of 24 is 8. 8 times 100 pi is going to give me 800 pi. So 800 pi cubic millimeters for that volume of cone. I hope I kind of got all those parts in correctly. It seems legit. The hemisphere, once again, instead of 4/3 pi r cubed, I'll be doing 2/3 pi r cubed because it's hemisphere, it is half of it. So although the radius, let's kind of split these up here as my last problem, wants to be finished. Although the radius of this one is 8 millimeters, we are just doing the hemisphere here. So like I said, volume of this guy is going to be instead 2/3 pi times the radius cubed. See if I can do this kind of in my head kind of stuff here. 8 cubed is 64. I always forget some of these ones here. 512, I think. Let me check that. 8 to the 3rd. Yeah, 512. So 512 here. That is not divisible by 3, as 8 is not divisible by 3. We got to double 512, we get 1,024. So that's going to be 1,024 pi over 3 cubic millimeters. All right, that is the volume of the hemisphere. Now, make no mistake, this is less than 800 because 1,024 is being divided by 3, somewhere in the 300s, right? Close to, 340, something like that. Pi, of course. But there it is. So the volume of the total here, we are going to subtract because that hemisphere exists inside of the cone, and it's like we're removing it, if you will. So I kind of wish they had it on the outside. Then it would be an ice cream, right? What's the volume of your ice cream? The volume of the total here is going to be 800 pi minus 1,024 pi all over 3 cubic millimeters. Now, I could combine like terms and play with that. I probably will just to humor you guys with it. They are asking us to round to the nearest tenth, but in case they ever ask for leave in terms of pi, hey, let's play with that a little bit. 800 pi is also 2400 pi all over 3. Multiply top and bottom by 3, get yourself a common denominator. It hit 25 minutes though, so that's okay. All right, so that's going to be in cubic millimeters. When you subtract that, that is 1400 minus 24, so 1376 pi over 3 cubic, not centimeters, cubic millimeters. And that should be an exact answer. Now, I did that one in my head, so I'm sorry if I did mess that little part up right there. I'll confirm the calculator that what I had before is the same thing as that one. So whether I do 1376 pi over 3 and get this answer of 1440.94, or I do 800 pi minus 1024 pi all divided by 3, I'm getting the same number. So I'm approximating this at 1440.9. At 1440.9 cubic millimeters, and that should be my final answer. Really hoping I made no mistakes on this one here, but if I did make any mistakes, I'll write it in the description section of this video down below, or wherever you find the description section on your YouTube video. Thank you so much for watching this one, guys. I hope that you understood a little bit about spheres. This does cover all the different volume things I'm doing. I'm not going to do any other obscure ones here. So we did prisms, prisms, cylinders, pyramids, cones, and spheres. We never dove into areas of things like pentagons, hexagons, decagons, things like that, and practiced with those unless they gave it to us automatically. Otherwise, we did tackle those volumes. Coming up at a later time, we'll be doing some surface area things, I do believe. So those ones get a little crazier, guys. You're going to have a little more trouble with those because even though they have formulas, there's still just a lot more things you got to pick apart with them. But thank you so much for watching this one, guys. I hope that this was a quicker one, cleaner one here. Take very much care.